Alright, welcome back everyone. Today we're going to talk about multiple. Let me make this a little bit less strong. So, multiple vector addition. And just like on the previous video, we were talking, it's the same exact thing we did in the past video, but except with more components, a little bit more tedious. So suppose you are given the x and y coordinate, and you're given three vectors. I have to change colors, and I promise I'll try to make this video less than 10 minutes because I didn't do a really good job. So the first one in our last video was 5 degrees at a 60, a vector of magnitude 5 at 50 degrees. Now we're going to make our second one. I'll just move our colors over here. Now our second vector was of magnitude 10 at 25 degrees. And now let's say we have a third vector where it's given magnitude 15 at a 45 degree angle. I think I might change from yellow later because it's not very visible. So now what we're going to do, we're going to treat each vector as if it was an individual vector, like we had said before. So let's break it down into its components. So we have first vector 5, 50 degree angle. You have your second vector, 15, magnitude 15 at 45 degree angle. And you have your third vector, magnitude 10, angle 25. As you can see, the proportion, they're not proportional and the angles are a little bit off, but just bear with me and follow the math. So what we're going to do now is we're going to break it down into each component. So we're going to break this into its x components. We're going to make a table. This is the way I do it at least. And then let me just switch to black to be more generic. X and y. So let's make a table. Alright, so as we had said, the x-axis, we can break each vector and treat it as a triangle. So now this will be the y and x for all of them. So now the x, from our previous videos, we know that it will be 5 cosine 50, 15 cosine 45, and 10 cosine 25. Now y would be 5 sine 50, 15 sine 45, 10 sine 25. Alright, and now what we're going to do to find the new vector of adding them all up is you're just going to add all the x's together and all the y's together. So after doing that, after you do all these numbers on your calculator, you find x total, which is what I'm going to call this. X total equal to 22.87. Again, unitless because I chose them not to be units. We'll shortly be talking about velocity and acceleration, which are a vector, and how to work with them. So y total now will be 18.66. Again, just put these numbers on your computer or your calculator and you will find this. Remember to always set your calculator specially to degrees, because if you put 45 radians, it's a complete different thing than degrees. So make sure it's always on degrees. So now we found our x total and our y total. Now remember from our last video that we said that to find magnitude, we do the square root of x total squared plus y total squared. Now, it would be the square root of 22.87 squared plus 18.66 squared. And that gives us 29.5. Now this is our magnitude of our new vector. Now remember, a vector has two components, magnitude and direction. In order to give them direction, because we know that all of them are over the x positive, we know that the new vector will be somewhere over here using the head-to-tail method, which I will show shortly. Now from our past video, again, we know in order to find the angle, we do the inverse tangent, specifically in our case because we were given these angles right here. We're going to do the arc tangent or inverse tangent of y over x, which in our case is going to be the arc tangent or the inverse tangent of 18.66 over 22.87. And that gives us 39.2 degrees. So now our final answer, which I'll make in red or maraschino according to this color palette, is going to be, our vector is 29.5, remember units, at 39.2. So 29.5 at 39.2 degrees. That's your new vector. So that would be your answer for the addition of the three vectors. Now, what does that look like using the head-to-tail method? Well, let me switch to black. Now the head-to-tail method, let's do them one at a time. So green, actually, going back to green, it would look like this. So your 5 vector at 50-degree angle, then your yellow vector, or your second vector, 15 degrees at 45. I apologize, I said 15 degrees, I meant 15 units at 45-degree angle. Now remember that I said earlier that you can imagine that there's a new xy every time. That will make it a lot easier for your calculations. And now our last vector, 10 at 25 degrees. 10 at 25 degrees. Okay, now our new vector, which we calculated over here, will be from our initial point, connecting all of them to here. So this red vector will be our new vector, which we calculated it will have a magnitude of 29.5, and the angle right here will be 39.2 degrees. So this is your magnitude, and this is direction. And your x and y would be here. So this new vector, the addition of the vector 1, 2, and 3 is the red one, magnitude 29.5, and a direction of 39.2. That's multiple vector additions, so if there was a fourth one, you would just do the same thing. Break it down into its components, add them all up, do the magnitude again using the Pythagorean theorem. In order to find the angle, do the arc tangent or the inverse tangent, which are the same thing, and you find the direction. So I hope that was helpful. Let me know in the comments if you would like any problem specifically addressed. Good luck in your studies. Remember, follow us on YouTube, subscribe to YouTube, and follow us on Facebook as well. Have a good day.